Hi, welcome to this video. I'm Wang from Hong Kong University of Science and Technology. Here I'm going to share with you our recent work about chemical evolution of secondary organic aerosol traces during High-PM2.5 episodes at a suburban site in Hong Kong over 4 months of continuous measurement. Attribute to a series of stringent emission controls during the past 2 decades, the air quality in China has been largely improved, as evidenced by the decreasing trend in the annual mean PM2.5 concentrations. But we are still facing the frequent haze pollution in recent years. Exposure to high PM concentration is associated with various diseases. Past studies examining the haze pollution indicate the significant role of the secondary formation during the episodes, but these studies are mainly based on the bulk measurement using the aerosol mass spectrometers. Knowledge about the chemical evolution during the episode is still quite limited, especially at the molecular level. In this study, we examined the PM episodes across the whole Hong Kong city using the data obtained from the 15 Hong Kong EPD general air quality stations and the HKUST Super Site. We define an episode occur when the PM2.5 concentration is higher than 35 microgram per cubic meter for at least 6 consecutive hours at more than 2 stations. And the red figure shows the geographical location of the 15 stations and the HKUST Super Site, which was marked in the red star. And the left table shows the statistical summary of the PM2.5 concentration during the episodes. Totally, we identified 11 episodes from July to December 2020. And among them, 1 episode occurred in summer, 5 in fall, and 5 in winter. And 3 of the episodes occurred during nighttime. We then calculate the maximum to minimum ratio to reflect the homogeneity of the PM episode across the city. And this ratio was calculated using the maximum PM2.5 concentration divided by the minimum PM2.5 concentration among the total 16 stations. So a ratio close to 1 indicating more homogeneity of the PM pollution on the city scale. We can see that the episode in summer to early fall showed a lower ratio of 1.4, while in the late fall to winter we can see clearly increased ratio, and these results reflect that the PM episodes in Hong Kong showed a more homogeneity during summer to early fall, while spatial heterogeneity of the episodes in winter was observed. The comprehensive chemical measurement was only available at the HKUST Super Site starting from the end of August to the end of December 2020. Figure 2 shows the time series of the measured PM2.5 and its major component, which are shown in the lowest panel, and different POA and SOA traces shown in individual panels in the middle. Here we mainly focus on 6 groups of SOA traces, which including biomass burning SOA traces for nitrochemical and 3 biogenic SOA traces, including 6 isoprene SOA traces, 6 alpha-penene SOA traces, and 1 beta-caryophenol SOA tracer, and 2 types of anthropogenic SOA traces for monoaromatics, DHOPA, and naphthalene SOA traces for phthalic acid. We focus on their concentration in the before episode period, which was highlighted in yellow in the figure 2, and the concentration during the episode, which was highlighted in green. Figure 3 shows the average concentration of 4-nitrocatechol and levoglucosan, which was widely used as the biomass burning POA traces during the pre-episode and episode period. And the lower panel shows the mass increment ratio of the two species for each episode. The mass increment ratio was calculated as the concentration during the pre-episode period divided by the concentration during the episode period, and was used to reflect the concentration changes. We can see that for the two species, MR value higher than 1 was observed for most episodes, which indicating that biomass burning is an important contributor to PM episode in these regions. And we also observed the variation of 4-nitrocatechol is consistent with that of NOx, and this indicates that the NOx is an important influencing factor to control the 4-nitrocatechol formation in this region. Similar figure was plotted for the two anthropogenic SOA traces. DHOP was the SOA tracer from monoaromatic such as BTEX, while the fructanic acid is the SOA tracer from naphthalene or methyl naphthalene. We can see that compared with the two species, DHOPA showed a clear seasonal contrast with higher concentration in summer and fall compared in winter, and this seasonal trend is different with that of the VOC precursor BTEX. And in terms of the MR values, the two species showed MR values higher than 1 for most episodes except for the two nighttime episodes, that is episode 7 for DHOPA and episode 11 for fructanic acid. And the variation of MR values also showed higher values during the summer to early fall. Besides, the correlation analysis shows that the two species, they both showed positive correlation with ozone, but DHOPA did have no correlation with the precursor BTEX. This result suggests that the oxidant is an important factor driving the formation of the two anthropogenic SOA traces in this region. The sum of measured isoprene SOA traces shows highest concentration in summer, which is consistent with that of the VOC precursor isoprene. By measuring multiple SOA traces, we can examine the compositions of SOA tracer. The results shows that the isoprene SOA in this region was dominated by the low NOx products, C5-alkane trials and 2-methyltetrals. This result reflected that the formation of isoprene SOA in this region was mainly while the HO2 channel under the low NOx conditions. Among measured SOA traces, isoprene SOA tracer generally shows the highest MI values, and the MI value was higher than 1 for all the episodes except for one nighttime episode, episode 6. And also the episode 1 to 4 had much higher MI values, which range from 4 to 11. And this result indicating that more enhanced isoprene SOA formation during summer and early fall episodes. Alpha-penny SOA traces shows the highest abundance among all the measured SOA traces, and the seasonal change shows higher concentration in summer and fall compared with that in winter. we measured 6 alpha-penny SOA traces, which including 2 early generation products, pinic acid and pinonic acid, and the 3-MBTCA, which was known as the late generation products from previous studies. And the composition of the alpha-penny SOA traces shows the clear seasonal variation. That is the higher proportion of the late generation products in summer and fall, while the higher contribution of the early generation products, pinic acid, in winter. And in terms of the MRI values, MRI value higher than 1 was observed for alpha-penny SOA traces for all the episodes except one nighttime episode, episode 7. Besides the concentration change, we also examined the PM ratio, which is the ratio of pinic acid versus 3-MBTCA, and this ratio was used to evaluate the aging of alpha-penny SOA. So the lower the ratio, the more aged alpha-penny SOA. And figure D shows the PM ratio for each episode in the before and during period. We found that among the 11 episodes, episode 1 to 5 and also episode 9 shows a clear decrease of the PM ratio during the episode, and this result suggests that the aging of alpha-penny SOA during the episode formation. Beta-caryophynic acid was measured in this study, and a similar analysis was done for this SOA tracer. It also shows high MR values under summer and early fall episode, and 3 of the episodes shows MR value lower than 1. Interestingly, we found that the beta-caryophynic acid show a different seasonal contrast compared with that of alpha-penny and SOA traces. The difference is that we found that this species shows less seasonal contrast. That is, we can still observe certain amount of the beta-caryophynic acid in winter. And also we found that the beta-caryophynic acid shows good correlation with the pinic acid, which is the early generation product from alpha-penny SOA formation. And this observation indicates that the beta-caryophynic SOA in Hong Kong is also relatively fresh in winter. And also we suggest that future work to be done to measure multi-generation beta-caryophynic SOA products to fully reflect this SOA formation under the episode period. This work was recently published in the Atmospheric Chemistry and Physics journal. If you are interested in, and you can go to the original paper for more information.